in general in the model and scenario applications, and that means dealing better with equity and justice. So we are going to cover some topics ranging from including that into the modeling, from going into investigations or empirical evidence on how to strain these ideas and put them into the models. We're going to talk about effort sharing, lots of interesting things. Just a note, maybe two notes to start with. So I'm replacing Chris Wong, who was supposed to chair this session today. I hope I will do as good as a job as he would have done. And the second point to note is that one of the speakers, Roman Ince, is unfortunately sick today. So he's in town, but he could not make it to the session. So that means we have one less talk to go through, and that makes the timing also a little bit less stressful. And that will also leave a little bit of space for interaction at the end to extend a bit the discussion. So thanks a lot. I'm really looking forward to these interactions, and I will start by asking Peter Verbroek to come to the stage. Peter is coming from the Institute for Environmental Studies in the Netherlands and is a well-known contributor to GLP.
Thank you very much, David. Good afternoon, everyone. So, what I'm gonna do in this afternoon is give you an introduction of one attempt to better include justice and considerations in modeling of land use. And of course, environmental justice is a very, very complex concept with many different dimensions. And there's no way we can fully represent it in models. But if we completely ignore it and don't take the imperfection, then we also have a problem of completely ignoring it. So, in this session, we hope to have gathered some examples of how you can deal with that in a modeling context. And one of the reasons for doing this is basically comes from the Kunming Montreal biodiversity targets, and the targets, the well-known targets, are the 30% targets. 30% of restoration of degraded ecosystems and 30% of land being protected area. And if we look at areas that are normally designated as being potential areas for conservation, or areas that are, according to conservation planning techniques, the optimal areas for conservation or for restoration, these are often located in the tropics. And so that was for conservation, this for restoration priorities. So we see these colors appearing a lot in the tropics. Now, if you look more carefully at those maps and start overlaying them with a map of where different people with different dependencies on the land are living, we see a large overlap. What we see is that those areas which have conservation priority or restoration priority are often located in areas where people are basically either doing subsistence agriculture or doing small-scale, market-based agriculture on land, where at least for their livelihoods, they're fully dependent on local land resources. And we know from a lot of academic papers that that can lead to conflict and injustice, because we can call it green grabbing or whatever kind of conservation grabbing, basically taking global priorities, global targets, being at the cost of often people with less power in the system and people with very high dependence on local land resources. So that's the starting point of that. And one of our analysis was also having just a look, is this problem really a big problem also for the future? And this is a map where we overlaid different scenario studies by global integrated assessment models of where would nature be restored and where would nature be conserved according to those models, and conservation planning approaches of what would be the best optimal locations to use as little area as possible for conservation to get maximum outcome. And the darker the color, the more frequently you saw those locations. And what we see, there's a lot of locations where are densely populated areas where people are dependent on land, so leading to conflict. So our question was basically, can we also imagine, can we do an experiment to imagine if it's possible to also find other solutions that are accounting for some more justice and avoiding these kind of conflicts that we see happening and that are often foreseen. So what we did was basically taking some elements into account. So, of course, we look at the biodiversity conservation targets, trying to protect the range of as many species as possible, and also different ways of how do you share the burden. Because often what we do in conservation planning is saying, and in scenarios, we put protected areas or restoration places where we can have best outcomes for conservation. What we did here is a burden sharing approach in a scenario where we say countries that have the largest biodiversity gap, as opposed to basically the difference between current biodiversity and potential biodiversity or regional biodiversity, they get a larger share of restoration. So that was one thing. We also looked at food production, and then especially at food production for people that directly depend for their livelihoods on those productive areas. So we talk about food security. And we made a combined scenario where we put all those considerations in one scenario to see, okay, is that possible? Can we find a land use configuration that will do that? So this is very much an experiment. Seeing in a modeling environment, can you account for those considerations if you implement that? So we have in the end these 4 scenarios. Here they come. So a business as usual scenario, which is an SSP standard IPC scenario. One where we put Kunming Montreal targets on top alone, focus on biodiversity. Then one where we have a scenario where we have the business as usual, that we avoid that smallholder agriculture is being converted or restored to nature. But we also avoid land grabbing for expanding large-scale agriculture in those locations. So we take two sides of the game there, basically respecting smallholder farmer autonomy in the system. So, and we have a combined scenario where we take the biodiversity targets and the food sovereignty targets into account. So we put that in a model, and of course we have to specify things and how we do it, but then the model could calculate what's happening. And overall, the world doesn't look very different from this very far distance if you look at it. Of course, geographic patterns remain the same. But if you zoom in, you see quite a few differences. And if we convert this image to basically what changes happened, you'll see that changes predicted are pretty different in those scenarios. You get very different pathways of change if you account for different objectives. So if we just have a look and we compare this business as usual scenario that we have here, we see these brownish colors where we see nature being continued to be converted to productive agricultural land. While in other parts we see more this intensification happening and other things happening. If we then look at this just conservation scenario, we don't see the brownish colors anymore because we have the biodiversity targets to conserve land. But we also see 2 different movements at the same time. We still see this intensification of agriculture happening, but what we also see is that some of the productive land is converted back to mosaics, more land sharing approach. So what we see, the model solution that we find is really a combination, very regional and context specific, of more mosaic land use types that have both productive and a productive and a conservation function. At the same time, you also see sometimes a sparing approach where functions are separated. So you see also even in an optimizing environment, you get these different solutions happening alongside at the same time in a context. Another way of visualizing these results is here. If we look at the scenarios and the shapes indicate kind of a range in outcomes across the globe, then what we see is that in the business as usual scenario, we see an increasing gap in biodiversity loss, and we see that there's at the same time, so we lose more biodiversity, we get also land conversions at the cost of people depending on land resources. So a lose-lose scenario. That's the trajectory we are on at the moment. If we only put in biodiversity objectives, we see that in a lot of range of things, the biodiversity gap is closed, or because we told the model to close it, so then it's closed. But at the same time, you see it even in some regions expands this injustice. So closing the biodiversity gap in the standard way comes at a cost. So if you don't take extra measures, there's a cost to reaching those targets. Now what we see that the same holds true for this food sovereignty scenario. You see then there's no unjust transitions because we told the model you cannot do it. But you see that it comes at the cost of biodiversity loss. Just is not always right in terms of biodiversity. And on the long term, losing biodiversity is not good for justice considerations. So also this scenario has its trade-offs. But we see that our just conservation scenario is in this sweet nice spot below there. So it shows basically that with otherwise the same model settings, the model finds solutions that are not crazily different from other solutions, but it's just allocating what to do where in a more clever way. So it's just an experiment. This is not a prediction, this is not what a prioritization of what we should do. It's an experiment showing that yes, if you put also more justice targets in such a model environment, you get different outcomes, and it shows that we have an option space to get alternatives in place. So that's the modeling exercise that we did. But of course, this is a virtual world. This is creating something from the helicopter above the globe. Okay, this is how the globe would look like. This is a vision, and we can reach that maybe. But that is very different, of course, from local realities where these things have to happen. And what I see always in communities that we work with is this big difference between people working with these large-scale models and people working on local realities that are trying to implement these more bottom-up participatory solutions to make this work. Well, the big difference is, of course, often how do you get that option space at large scale? How do you navigate powers in the system? Because there are different people involved in allocating the land. It's not as simple as in a model where we just change a pixel and it works. In reality, people own the land, people have power on land, people have power on the outcomes. So, in the end, you need local processes to make it happen. But I'm also skeptical about disposing all of these modeling results and saying we have to solve everything locally. The biodiversity crisis and the task at hand is that big that we cannot make it work all from the bottom up. And from the bottom up, we have to account, of course, for all the different actors that are there and their different parts of the game they play. State power, local autonomy of decision makers, value chain power, and all of those things. And I just show you as an example a little bit of the work we did trying to map out those power networks in land use decision making. And we did a review of 70 papers that described decision-making structures and how power is organized in those decision-making structures, and we tried to map all those networks. So we got this whole set of networks, and we could synthesize them to a few more archetypical networks. So we have here these different things, where you see here more on top, you cannot read it. It's agro-industrial control networks, where the power is very much concentrated, collaborative networks, and civic food networks that are maybe on the right side of the game. So you have to transform all of those things. But in evaluating this in more participatory planning things, we see that often doing it from the bottom up, it breaks up in certain places by kind of power imbalances, leaderships, distrust issues, and so on. And what I believe is that we have to leverage this interface between using top-down approaches, land use planning approaches, which can be supported by modeling exercises that I've shown, with these kind of bottom-up approaches, inform them to basically get the system right. But that's like going beyond this modeling exercise in a very short way to also just show that we're not claiming that we can do environmental justice fully in modeling. We can use modeling to help making right decisions in the way we implement these things. Thank you.
One or two, one question. We have time. Okay. Does anyone have a question? You have one?
Hi, Peter. Ana Paula from Brazil. And what data for this land structure, the agrarian structure, you use it globally? in the first model.
Yeah. What we did is trying to go beyond land cover data. We use land system data, as we call it. So we have basically combined all kinds of data about land management, the land cover, also the composition of how we work with grids of 9 by 9 kilometer. We also have distinguished ones where there is a mosaic of land systems there. And we have used this map of the reliance on land. It's based on a large analysis where we have all kinds of local case studies, local evidence that we got from many places in the literature. We put as dots on the map, and we used clever techniques to make it into a large map by looking at similarities between locations. So these maps are not always data, they are also kind of a synthesis of the knowledge we have, with all this imperfection. That's why I'm also saying these are not predictions, they're experiments, but they are experiments of a representation of the world which is based on some data and some of our knowledge that we have, because we do not know a lot of different decision-making mechanisms around the globe in exactly what location. So it's a large effort that's underlying this experiment, but it's needed because you cannot just use a land cover map, because this is much more than just land use.
Any more, maybe one more question? No? Okay, I think then we can move on. I guess it's me next. Standing here so you can see all the slides. So the background for the study that I am introducing you today is also the Kunming-Montreal Global Biodiversity Framework, which is probably, as you all know, it's our post-2020 strategy that has this overarching goals that address outcomes for biodiversity and nature's contributions to people, and 23 action targets that are to be achieved by 2030 and are supposed to address these direct and indirect drivers of change. Now the thing is that these targets are being formulated globally, but they will be implemented at the national level via so-called national biodiversity strategies and action plans, where the member states to the CBD have to formulate national targets to address each of the targets in the global framework. And this kind of poses the question how to share the efforts or the benefits and burdens related to that between the member states. And one form of justice that is related to that is distributional justice. This is a form of justice that looks at how benefits and burdens are distributed, and it comes with a lot of different patterns. There are many distributional considerations how you can share benefits and burdens, and there's no ideal pattern really. It's more that each of these patterns make assumptions, and they also come with trade-offs. And one example where this has been applied is a study by Lucas et al., where they looked at planetary boundaries and they translated them into types of global budgets and distributed them between large economies according to 3 distributional principles. In this case, it was grandfathering, a sovereignty principle, equal per capita, and ability to pay. And what you end up with is that you can look how these different principles would play out in terms of who is getting how much of this budget. Now, what we are doing here now is applying a kind of similar approach to explore different options of effort sharing towards the target of the GBF. And I would like to exemplify this here with a nutrient loss target. This is part of target 7 on reducing pollution, and the target is to reduce excess nutrients that are being lost to the environment by a half. We can translate this roughly into a budget of, the current nutrient loss globally needs to be reduced by 50%, how to distribute that between the member states. In order to look into this, we focused on the agricultural sector, and we focused on the metric of nitrogen surplus, which measures all the input of nitrogen to agricultural areas from fertilizer, manure, deposition, fixation, minus by what you take out with the plant mass, and then you have the nitrogen that ends up in the field and eventually in the environment. We use data on nitrogen balances over global cropland, and we also use published data on regional environmental boundaries for nutrient loss over arable land, and these boundaries consider thresholds for aquatic and terrestrial eutrophication and for good drinking water quality. What we did then is that we distributed this global budget. So this is focusing on this nutrient balances. If we aggregate them globally and we reduce them by 50% for the member states of the CBD, we end up roughly with that budget. And now we distributed that budget between member states. And here I show you also some larger world regions and the least developed countries according to the UN. And we distributed that to 5 different distributional principles. First, we have one that we call efficiency, where we distribute it in a way that those nations that use their nitrogen efficiently with a high nitrogen use efficiency currently will get assigned a larger budget. With the idea in mind that like this, you can produce more by losing less nutrients. Then we have an environmental capacity principle or scenario where we simply use these regional boundaries and aggregated them up. And this is the idea that here we really look at the capacity that the environment has, and that is how we distribute our budget. Then we distribute it equally to the cropland area, meaning that then some nations have to reduce more than others and everyone gets the same ratio per cropland allowed. We have the grandfathering principle, which might be a likely adopted principle, meaning that everyone reduces simply by 50% so that the relative shares in the global budget stay the same. So that's a sovereignty principle, meaning what I have acquired is kind of seen as mine, and then countries or regions that currently contribute a lot will also be allowed in the future to contribute a lot. And last but not least, we try to approach a sufficiency scenario where we said the idea would be that each region should be allowed to have enough nutrient loss to be able to produce enough food for their inhabitants. So we distributed the nitrogen harvested in an equal way per capita, but then we had to, well, if we assume linear relationships, we had to improve the nitrogen use efficiency. And the thing is, with what I'm showing you here, this is also not meant to be like a blueprint that now this should be the national targets, but this really is supposed to initiate discussions around like, what is our idea, how this should be distributed, and which nation should contribute what, and what would that mean? Of course, we can also look then at a lower level, so here exemplified for the European Union, and this shows you very nicely the differences. It shows you that under the environmental capacity, and probably most of us would say that should be, or at least the natural scientists would say that should be how we distribute it, we would get a much, much smaller budget assigned compared to, for example, the grandfathering or the efficiency, and even smaller than the sufficiency. So how should we go about this? And another follow-up question that you can have with that might also help to decide this or negotiate this is, like, how do these distributional principles relate to different worldviews or different value systems that people might have? And in order to explore that, what we started is that we align these distributions with pathway narratives that we also developed in the same project. And these are 3 pathway narratives that all should lead to positive outcomes for biodiversity, climate, and people. They are building on some existing pathway narratives, and we fed them with the Nature Futures framework and other like value and justice considerations. And just very quickly, we have one that is like green growth, like where we have a nature for society, value for nature, and we focus on green innovations, on market regulation, on efficiency. Then we have one that we call need-based and nature-connected local stewardship, where we value nature mostly as culture, so for relational values, and we focus on local production, local consumption, and subsistence. And we have a global stewardship one, where we have a mix of nature for nature, so intrinsically valuing nature and nature for society. And we have these global governance systems and expert-driven decisions. And then the question you could ask is, under these pathways, which would be the most likely distribution for these burdens or for these benefits that we choose? So maybe we could think that under the global green innovation, we would favor an efficiency distribution, while under the local stewardship, sufficiency would probably be our idea, because on the one hand, we want that everyone can produce locally what they need, but at the other hand, we want to cut overconsumption, we want to cut luxury consumption. While under the global stewardship, with this expert-based decisions and also this nature for nature focus, we might look at the environmental capacity. However, this is just our internal considerations about that. What we plan as a next step is, in addition, we will have other targets, but what we also plan is that we would like to have some stakeholder engagement on the alignment between these pathways and the value systems and these distributions. And so if you're interested in what is coming out of that, stay tuned, and that's it. Thank you so much.
It's time for a couple of questions.
Yeah, thank you for your talk. I'm Benjamin from Kassel University. Could you briefly elaborate how you define environmental capacity? So which factors were considered in your calculations? Thank you.
Yeah, you're welcome. So this one is really the easiest one because it bases on published data on these environmental capacities. So there's this study by Schulte-Übbing et al. From 2020 where they really, with a big modeling framework, they try to infer these local boundaries for how much nutrient loss would be acceptable over agricultural land, also given nutrient loss from other sources. And what we did is that we said under this scenario, that would be how we distributed, that would be our maximum. Yeah.
Thanks very much. One question, if you would like to scale this down to a national level, for example. From my point of view, it's probably the easiest for countries to adopt a practice based on grandfathering, just because every country is aware of what has happened in the past. What are pathways to, make it appealing for countries to choose a different approach?
Yeah, I mean, that is a very good question. I think what would be important is that these kind of studies would be put to the policy and science interface, right? That we communicate these ideas to where these negotiations are being made. But as far as I'm aware, there's not really a negotiation in place, but each nation is independently of each other making their national targets, right? So we really hope to kind of spark this idea that maybe we should think bigger than just everyone setting their national targets. But I think all we can do for now is communicating it in the right positions and then see how this will develop.
Thank you. Craig Beatty, World Wildlife Fund. I love that you chose Target 7. Have you thought about doing this with any of the other GBF targets?
Yes, yeah. So currently we also want to look at the protected area target and then at Target 16, the consumption target. They're focusing on the land footprint of consumption because in that project it's mostly about agricultural production and consumption. So land footprint of consumption is also something that for now, and then maybe in the future there will be more, but for now this is what is planned.
More questions? If not, then thank you very much. Oh yeah, there's one.
Hi, I'm Annie from University of Edinburgh. I'm not sure if I understood this fully, but I'm just wondering, of all your scenarios of distribution, you spoke about grandfather, which is about what you already have, you keep and you reduce by proportion. Were any of your scenarios about acknowledging what you have and redistributing, so as to speak to people who've been hard done by in the past, and in the context of loss and damage or reparations, can we make a case to developing nations about any of these different scenarios? It might not be so relevant for nutrient surplus, but for some of the other targets it might be more relevant.
Yeah, I mean, that's a very good question, right? Like, this historic responsibility is also an important point in these discussions. Like, right now, we haven't really approached this. Maybe, like, this equal per hectare comes closest to it, because it means that those countries that currently heavily put nutrients out in the environment have to reduce more. But just from a discussion perspective, I would also say maybe in the context of nutrients, that would also refer to costs, and also in other, like sometimes it's not only about like how do we distribute the actual protected area or the actual nutrient loss, but it's also the costs that come with this. How do we distribute them? So maybe the historic responsibility would also be an important aspect that comes in with distributing these costs. But so far we haven't tapped into that yet, but it will definitely be part of the discussion and something that we have in mind. Thank you.
Thank you very much.
And my topic is land use modeling in times of interacting crisis. And I came to that topic when I first talked to my colleague, which is also here, but I will not name him now, at the beginning of my PhD. And I think he told something to me like, it seems that we can only model how we destroy ecosystems or how we destroy the planet, but we have a hard time in modeling how we save the planet or ecosystems. Something like that. And I really got interested into that. And therefore I did a literature study on the political aspects of integrated assessment modeling and a critique of their use in science or the scientific practice. And for me it turned out to be even worse, because it seemed to be like, okay, we're not only having a hard time, it's also that certain modeling practices, or in the way it is done, it stabilizes the crisis-ridden societal conditions. And how I came to that result, I first need to explain you some terminology that we speak the same language. So when I speak of critique, I mean a normative endeavor that applies a certain set of values, and it's a normative approach. And I try to relate isolated critique to the overarching societal conditions, which is in line with the Frankfurt School of Philosophy and their understanding of critique. And when I speak about societal conditions, I mean the dominant logic of a society, which means it's a logic that structurally suggests certain behavior and relation towards human and non-human nature, or between human and non-human nature. And as a working definition, I understand it as a logic of exclusion, which means it's structurally suggested to satisfy needs on the expense of other humans or non-human beings. And I further want to define projection as a future that maintains the current societal conditions, and a utopia, following Venier-Cambron, as a possible reconfiguration of the existing and the potential towards other societal conditions. Okay. So how did I came to that? I read a lot of literature from science and technology studies, and they apply a huge set of lenses, frameworks, or concepts, and apply it to a critique of modeling. And they reveal what I call a stabilizing function, because if they show how the politics of knowledge production, and then they usually, or most of them, show how, if this is not taken into account, stabilizes the crisis-ridden societal conditions. And I will only speak about 3 of them. It's really small now, but I'm going to start with the right-hand corner of co-production. It describes the co-production of society and knowledge. So there's no isolated knowledge production. And that is because what we know about the world and how we represent it, for example in models or elsewhere, and the world we want to live in cannot be separated. It's entangled in social norms, discourses, and so forth. Another concept that I want to mention is called boundary work. One speaks of boundary work when categories or elements are assumed as natural or legit or rational, and then it's implemented, for example, in a model. If we model the human environment interface, we have to make certain assumptions about human or nature or societal nature. And of course, this influences what kind of knowledge we produce and for what futures do we produce knowledge. But it's usually hidden in, we do not directly speak of it because it's quite obvious for us. And then I want to speak about world-making power, which is quite interesting in relation to them. And that's an analysis which showed that models are not just tools, but they have an agency on their own, an agency on their own, and because they produce results and really powerful futures, and they impact the policy processes. And we have to think about it and what it means for a modeling practice. Okay, so I'm trying to understand how these different things work together, and I found out that the missing piece from the in the literature was the piece of ideology, and that's the way how I conceptualized how scientific practice, ideology, and societal conditions are intertwined. We're going to start in the right-hand corner with the societal conditions, which are embedded in the economic structure or in cultural norms, for example. And the societal conditions, as you probably know, are fundamentally unjust and crisis ridden. We have like a lot of like the climate crisis, biodiversity crisis, social justice, and so forth. And because we as individuals, but also as society as a whole, we somehow have to deal with that. And there comes the ideology. Because ideology tells us, okay, there's no other way to do it. That's the only possible societal conditions. That's the best world that we can live in, or there's no alternative. And of course, that is not always like scientifically given, but it's like ideology, and nobody's free of ideology. And according to Rahel Yegi, ideology forms and limits the possibility space, because by saying there's no alternative, we stay in that social conditions. And that, of course, informs our scientific practice. And if we accept it and don't speak about it or do something different about it, we stabilize that ideology. And during the scientific practice, I already told you about the stabilizing functions. If we do not actively take them into account and take into account the politics of knowledge production, it's really likely that that our scientific practice legitimizes the societal conditions. And then we are in a loop and we cannot come up with other possible futures that may be not that crisis-ridden. And why is that a problem? For me, it's a bit provocative now, but it looks like a Hollywood superhero approach. If you imagine the superhero tied to a chair at the end of the movie, the evil guy is explaining his awful plan, and in the last minute, the superhero is able to free himself and throw the bad guy into a shaft. Then he goes back home, and everything is fine. But it's not really ambitious, because the mantra is always, it should not become worse, but it should remain bad, because all the context around it in the world is ignored. It's only about that one bad guy. But of course, there are a lot of problems in the world which are not addressed by the superhero. And I think that's a problem in times of multiple interacting crises, because we cannot just deal with one part of the problem, and there's no conservation, so we cannot just try to conserve the actual social conditions, because they are so crisis-ridden. It needs to change. And since the multiple interacting crisis affects all aspects of life, we need to think about futures that also transform all aspects of life. And therefore, I want to suggest a systematic explanation of utopias that question the societal conditions. And that sounds quite a bit, maybe a bit meta, or like, it sounds complicated and a bit philosophical, but it's not that hard, I think. And there are some examples how that can be done. There's, for example, the categorical utopia framework by Superlity et al. And it's based on 3 assumptions. The first is that the dynamics of the multiple interacting crises can be understood and described in scientifically derived categories. And then we can come up with a categorical utopia that, based on other categories, that breaks with them. That means it's not an exact utopia, but categories, like other workings, other logics of the society, and we can build multiple utopias based on that. And then we need also to build this categorical utopia based on a theory about the individual human, like a psychological model and a societal model. And then we can have like a really good scientific discussion on these things, because we can critique the underlying social and individual theory. We can say humans are not like that, so your results are not good. Or we could critique the relationship between the theoretical basis and the utopia that we think of. For example, like with that assumption about human, we cannot get to that utopia. Or we can also critique like the problems of the inner logic in the categorical utopia. And another approach, I think, which we are doing in our session on Thursday, and which we also discussed a bit here today, is about anticipatory or participatory futuring and doing participatory methods to come up with other possible futures, which are maybe we as researchers can come up with. So to conclude, I found these stabilizing functions, which are likely to perform by modeling practice if they are not taken into account. And I figured out that ideology is the missing mediator in the literature, which is mediating between societal conditions and scientific practice. And we need to take them actively we need to take the stabilizing functions actively into account and think about the politics of knowledge production. And I also told you about the categorical utopia framework. Thank you very much.
Thank you. Any questions?
Hi, thanks for this very interesting talk. Yeah, I don't know if this is a question, but I've been thinking about this myself a lot as well. And every time I try to find ways to model or to model pathways, utopian pathways or so, I realize that these stabilizing functions are so deeply entrenched in the nature of modeling, such as the scale, the quantitative input data, the model objective function, or like what integrated assessment models seek to achieve, basically what's their engine. And yeah, I don't know, just what do you think?
Yeah, I think I totally understand you. I really had the same impression, and I also were thinking about it quite often. But I think it's also like, since we live in this multiple interacting crisis, it's not enough to have only quantitative knowledge about problems. We need to have we need to have qualitative and quantitative knowledge about it, and we need to combine it in a way. That's what I think about. So models can be like one part, but maybe they also need to be used in another way than to do that. Thank you for your question. Sorry, I forgot it.
Maybe I have a question for you as well. To what extent does this hold for integrated assessment models, or does it also apply to many of the other scientific techniques, and maybe even what you propose, the art of giving critique on approaches or participatory methods? Are they also not reflecting these deeply entrenched systems in society? So to what extent is your findings, are they specific for integrated assessment models, or are they more general?
Yeah, thank you for that question. I think it's quite general, but since integrated assessment models are so policy relevant, there's a lot of literature on the critique of them, because social scientists or science and technology studies study them quite intensively because they are so policy relevant. And I think it applies to a lot of other models as well, like all this, what I mentioned with co-productions or the sociology of knowledge production. We have that in every discipline, I think. Yeah.
Thanks. Anybody else?
Hi, Sören Lindner from IIASA in Austria. Thanks for that also really interesting talk. I just have a question for you. So I think IAMs ultimately provide a solution space for evidence-based policymaking, right? Scientific evidence-based policymaking. And I wonder what your answer is to that inherent problem which is that we are trying to solve future problems by changing action now, right? I mean, do you have alternatives to evidence-based policymaking?
I'm not sure if I understand correctly, but I try to answer your question. And I'm not sure if it's evidence-based enough, because when there were like crises like that, there are a lot of examples. For example, in the work of anthropologist David Graeber, which is, for example, in his book *The Dawn of Everything*, where he showed that societies fundamentally changed and adapted to their crisis, which is possible and happened quite a lot in history. So, like these large-scale transformations take place. Yeah, does it answer your question? Or you can also try to rephrase it. Okay.
One final question. Let's over there. Yeah.
Thank you so much, Felix. That was fascinating, very thought-provoking for everyone. I was wondering if I mean, your last slide seemed to suggest all modelers in the room maybe should throw out their work and start again with, different. I wonder if you've thought about ways in which people can take this kind of thinking to reflect on what they do, ways that they can discuss it better, understand the limitations. I know that a really interesting kind of thought piece came from, I can't remember his name, but a guy from the UK who works at the Chatham House policy think tank on food systems, and he's speaking to food systems and land use modelers and saying, effectively, we need to think about a different political system to affect the change and transformation we're talking about. And researchers have a responsibility to start by introducing their modelling and saying, I'm someone who believes we can have transformational change, like a different political system, and therefore these are the pathways in my model. Or I'm starting from a point that we will always be a neoliberal capitalist system, and my model reflects the pathways under that system. And until we admit that and reflect on that in our work, speak about it, we're giving kind of false information, false evidence to policymakers about a very narrow stream of options that they have, because we're not thinking outside of the systemic box. And that was one way he gave quite practical advice that researchers could write literally introduction paragraphs in their work about this. I wonder if you've got kind of reflections on what you would suggest modelers do with this kind of thinking.
Is the time over?
It's short.
Okay. There's first I try to compile a reading list on that, which also includes YouTube videos, because I understand that not everybody can read all these papers before they do the rest of their work, and which should be accessible for non-social scientists. And I think there's also examples in other disciplines. For example, in water modeling, they have a discourse on that as well. And yeah, maybe that helps you. And thank you for your comment.
Thank you very much.
Thank you very much. Well, I'm glad to present today this work that we have made, not only at IIASA, but also in the Fable Secretariat with the different institutions, and also in collaboration with the Fable Consortium. So it's titled Cooperative AI for Global Trade Consistency Across Long-Term National Pathways for Sustainable Land Use and Food Systems. So it's what we call, or what we use at IIASA as the Smart Linker platform. So first, I would like to introduce what are the fabled senatons. Senatons were created, the concept of a senaton was created at IIASA in 2019. And the word came from Michael Obersteiner, and he created the word before the senaton take shape. And basically, it's a word that comes from a marathon of scenarios. And this is the shape that these senatons took with the Fable Consortium. And the concept of the senatons, it's a participatory decision-making exercise to integrate models and stakeholders to solve complex problems. So we have a bottom-up and iterative methodology. In the process, after each iteration of senaton, we balance trade inconsistencies using, at this point, from senaton 2019 to senaton 2023, a method that we call the proportional trade adjustment. So the senaton, it's a bottom-up approach. We have in Fable more than 20 countries participating in the senatons, and each country team uses a land use model, integrated model, which we call the Fable calculator. This is already integrated model. And then with the senatons, we integrate all the outcomes from the country and we align them to the global. So we have global targets, and we measure the contribution, or how close or far we are from these global targets after each iteration in the senaton. But it's very important after each iteration to check the consistency of trade, because we have learned in this exercise that the system, the global system, is very sensitive to trade. And for example, during the Senaton 2023, it was made between May in May 2023 with FABLE consortium members. 22 countries participated. We had 6 rest of the world regions represented in 28 single models of the FABLE calculator, each of them like at the national level and regional level. We had 83 commodities. The FABLE calculator takes in consideration 5-year time steps between 2020 and 2050, and 2020 is a calibration period. Until 2020 we have a calibration period, and we make the trade adjustment for each commodity of the 83 commodities after each iteration. So yeah, then when we adjust trade, then trade becomes exogenous, and we input the adjustment to all calculators to keep the global consistency, because at the beginning, when each country submits their pathway, they make assumptions on what's happening in the rest of the world, right? So one country can assume, and this is the problem I will show you today. We have been experiencing this problem or this situation since the first Senaton we have in 2019, and it's the case where the US. So you have an idea of how sensitive is the system, for example, to diets at the national level. The US make a change in their pathway on the sustainable pathway. They change their diet. They say we will not eat more meat, so we will export meat. And this brought to the system a new beef exporter that was not considered by the other exporters like Brazil, Argentina, etc. And this was also the case that the Chinese said, okay, we will reduce our beef consumption. So at the end of that Senaton, we have an overproduction, a surplus of beef at the global level. And this is what we need to adjust after each iteration, because of course this affects our global targets massively. So we have three scenarios. We have the current trends, which is what happens if we don't act at all differently. Then we have national commitments, where each country consider their national commitments only, or their priorities at the national level. And then we have global sustainability. What will happen if national actions and policies are aligned with our global sustainability targets, or if all countries concentrate on achieving the global targets, more or less, forgetting about national priorities. So this is what this method can balance, where each country can submit their contributions based on their own expectation, priorities, etc., and also considering the global targets. So after Senaton 2023, not even on our more optimistic pathway, that is the sustainable pathway, we could achieve all targets. But you can see, like, for example, that for emissions of the climate change mitigation, we were very close on the sustainable pathway, for example, but not that much on food security. Water also was not that good in the first two, etc. So what we do with the Smart Linker platform, this is a model we have been developing. This example I will show, it's like a proof of concept of what is the Smart Linker. But it's a model-free reinforcement learning. We are adapting the algorithm of performance learning to work in a multi-agent way, because we have, for us, every country it's an agent, and also multi-objective, because we have multiple global targets. So we need to consider also these objectives. And so this approach is crucial to managing the complexity and also the dynamics and the interdependencies of the distributed assessment model developed for the FABLE scenarios. So this approach fosters coordinated and effective solutions for sustainable development. So the smart linker is the central coordinator, optimizer capable of learning by interacting with independent agents or countries or regions of the favorite calculators to solve these complex multi-objective problems. As I mentioned, each country for us is a favorite calculator. So this case of study is the Chinese beef exports. We measure with considering all the submissions from the countries on the sustainable scenario, what was the product that had more impact on our global targets. And this product, of course, is beef. Number one in the list is beef. So we started optimizing beef. We also selected what were the main players, considering the submissions we received during Senaton 2023, what were the main players for beef trade. And in this exercise, and at the point of this study, these were the agents with China, Argentina, Brazil, India, and the US. We consider for this exercise only the minimizations of emissions from Apollo, and we used a local constraint that is kilocalorie consumption per capita should be between 10 and 50% above the minimum daily energy requirement for MDER. So we act, or the algorithm acts using these three elements that are actions, rewards, and penalties. So the linker tries different actions with the calculators and measure how well the system is performing. If it's a good action, the one that performs, this is bilateral trade. When it tests an action of trade, a bilateral trade, it evaluates, it gives a high reward if it's good for the targets, or a penalty if we don't meet this restriction of the kilocalories per capita. So this shows in simulation like the different experiments or different what the linker experienced during when it was learning, and these are the rewards or the Q values accumulated. And the green line shows that the linker was able to select the best action on bilateral trade during the whole period. And this is the resulting scenario. In the sustainable scenario, we could see the dash line is the sustainable, and we see a reduction in some of the years for the smart linker. And I think more important, or it's how the linker select or change. The dashed line is what the country submitted. We can see how Brazil submission was much higher than what was the optimum that the linker select, and this is already considering the US exports, the new player that is the US. Also, this was considering a function of stickiness. So the changes in the beginning of the period are more are related to the historical data, and then on the next years has more freedom to select. So then we see that we could improve emissions on our target year, that is 2050, and we could remain on the limit or the values for the kilocalories per capita, the MDER, and we could improve or reduce emissions with the adjustment from the linker, compared with the adjustment that was already made with the proportional adjustment that already includes the first submission that the country sent. Yeah. So these are the emissions from the countries, so for the exporters. And I will go to conclusions. So this approach seeks to support countries' integrated plans and agreed security conditions to optimize bilateral trade with respect to planetary boundaries. At this point, what we're considering in this work is the optimization problem. It's seeking the performance to all global targets, considering national restrictions as the kilocalories per capita. We're seeking a collective intelligence. The smart linker identifies synergistic trade relations, manage the collective intelligence of participants, maximize collaborative benefits toward common goals. The sensitivity to trade changes. Experiments with the Senaton data from 2023 and prior show sensitivity of global targets of emissions, forest, land cover, biodiversity to changes in bilateral trade of beef, which is, I think, important that even with 1 year bilateral trade volume, it gives us the global system is sensitive, for example, emissions, depending who is exporting that year to China, for example. So it's very sensitive. It highlights the crucial role of trade policies and agreements in achieving towards the sustainability. It has a flexibility in collaboration. The distributed approach offers flexibility for international collaboration. Our future work is broader inclusion to include all major importers and exporters. Right now, we are already working with a bigger set with all importers and exporters of Senaton 2023. And this is ongoing work. We also will continue with the rest of the products to conclude all the Senaton. And the purpose for this year is to have all bilateral trade for the 83 products for countries and regions, include the current trend and national commitment pathway, because right now we're working with a sustainable pathway. But of course, the current trend pathway is the improvement is even higher than the sustainable because it's more trade has more place to play. And we also presenting the option of the open Senaton infrastructure, when the favored countries can submit they don't have to wait for a Senaton globally, where they can submit their calculator and have the alignment of their trade based on what it's the rest of the world, so they can have their automatically the trade adjustment out of the coordination of the global Senate. And these are our participants for the Senaton 2023. Some of them maybe are around here, so thank you very much for all your contributions, because this work is not possible without the national models, and we will be contacting you when we have like the final version for the year for the bilateral trade with this method of the small link. Thank you very much.
Two questions there.
Thank you very much for this research and model. My question is this model could be very sensitive to the starting point, because the model looks like a market chain or time series chain to me. In your example, for example, China reduced 100 million tons of beef consumption, but if we change the number from 100 to say 99, anyway, the number changed a little, and the result could be very completely different given its time series nature. So is this model considering this starting point sensitivity?
Yes, it considers the whole time period, and this is actually the behavior not of the linker, but as a consequence of the behavior of the national models that are the fable calculators. So yeah, it's sensitive to changes. It depends on your starting year and how this it's evolving through the years.
Hi, great to catch up with where Fable is at, having been involved early on in the Australian team. So thanks for that. My question is around the use of kilocalories and a minimum kilocalorie dietary requirement, and the sensitivity of the model to other diets or considering other micronutrients or protein, vitamin B12, that sort of thing. How do you think a broader definition of diet or micronutrient would affect the results?
Maybe my colleagues can expand more on this. My experience is with the experiments we have done, it's that the national models are extremely sensitive to diets. So just by changing a diet in a country, you can actually see a change at the global level depending on the country. But yes, they are very sensitive to diets. We haven't observed in this global experiment like a huge or important variation on the kilocalories per capita without changes in diets, just with trade, for example. At that level, it's minimum, the change. The more important change is at the national level when you change a diet in a country. I don't know if it is...
Final question, yeah.
Hello, hi, it's Camilla. My question is, I will rely on the example you made about US and beef consumption. I was wondering, like, if in US we decrease a lot beef consumption, and thus, like, we increase the beef availability in the world, and thus, like, other countries need to decrease the export of beef because now we have US. How it is decided how much each country decrease their export and thus their production?
In this exercise, like in this perfect simulated world, where basically the country that is more efficient towards the global targets is the country that will have more priority of increasing their exports. We want to include, we measure other for example, cost of transport. It's really marginal, so there's no big deal. This was done by my colleague Federico. He measured the cost of transport by ship, and it was marginal. We want to include production cost. We don't want to include tariffs because that's what we think it can be adjusted as a policy in the world, so that more efficient towards global goals countries can have lower tariffs for those trade, like those efficient trade relations, for example, like I don't know, China, US, China, Brazil, etc. So they have a lower tariff, and this can actually promote this more sustainable and fair trade.
Thank you very much.
Thank you very much, and a big applause also to our Fable colleagues and the developers of the Fable calculator in the Secretariat and also at the national level. Thank you very much.
Thank you very much. I would just like to have another round of applause for everyone.